Hello. So here is the lesson today on Unit 3 from sketches to products. We're going to start with the slideshow. So in the slideshow on slide 2 is the podcast. You can listen to the podcast instead of reading, or you can listen and follow along with the reading. This slideshow will be here on this podcast slide if you need to refer to it as well. In this lesson, you will learn to describe fundamental processes needed for a project, including design and prototype development. You will identify chemical, mechanical, and physical properties of engineering materials. You will be able to assess risks and benefits of a design solution, and you will be able to maintain a professional portfolio, which is going back to your engineering design project. So chapter 1 talks about visualizing your work. Visualizing your work is going to be talking about your sketches. Okay, so in any major engineering project, you're going to have some drawings. So drawings are typically to scale drawings. And if I were there with you, I would show you an engineering scale ruler, um, which we have in the classroom. In this unit, you're going to do some engineering sketches and learn how they affect an overall design. So a great starting point for most projects is a quality sketch. So a sketch, the purpose of a sketch is to kind of visualize out loud what it is that you want to design. And it also helps you show other people what is in your head and what it is you want to do. So anybody that you're working with, any project personnel that you're working with, you can show them what you're thinking without expressing them in words. You can provide a glimpse of what it is that is going on in your head and what it is you want to create. So some typical designs. Uh, I've seen designs on napkins, on paper, obviously on paper, and on tablets. Actually, the Herky model, the Herky symbol was actually designed on a napkin. So, and then he patented it. Here are some important points to remember about a sketch. It requires considerable time and effort. Sometimes it really doesn't, honestly, but sometimes it does, depending on how specific you want to be. You need to choose the right equipment. So optimal visual products, having a personal sketchbook. Um, if you want to really sketch a lot, we know those artists that sketch a lot have their own sketchbook. Perspective is critical to an effective sketch. That is true. Engineers usually use a specific perspective when they sketch. It's called isometric sketches. And then there are different types of sketches. So depending on what your project needs, there are process sketches that address how well the assignment is understood. There are ideation sketches, are part of the process designers use while developing ideas. They're basically rough sketches. Explanatory sketches explain various aspects of the design concept and are clearly written for possible clients. And then you have your persuasive sketches that are finished products, usually created in a digital software program. They express potential investors with colorful details, appealing concepts. So those are the ones that are going to wow you and make you want to buy that product. So these are actually in the quizzes and in the assignment. So you might want to keep this in mind, that these answers are in your Google drawings. And then, are drawings dead? Please know they are not dead. Sketches are time consuming, but these are the problems with sketching. but they are very important for 3D objects, computer-generated picture projects. Um, I use them for green architecture sketches when I build houses, and then I use those to put them in Revit drawings. So sketching is very important, and it allows ideas to come alive. Engineers should focus on how to improve sketching. You can sketch digitally as well as by in paper. So some people have learned to sketch digitally as well. Prototypes and materials is chapter 2. So in this one, you're going to learn the fundamental process, basic tools that engineers use to conceptualize their designs. The fundamental process consists of basic strategies to meet goals and achieve understanding. How sketches become products. So what you're going to do is figure out what a prototype is. Basically, a prototype is an initial model of a product. It is usually a machine of some sort. It is designed or developed to test your constraints or your criteria to see if you can build this in real life or in large scale or in real scale model. Okay, so a prototype is usually a simple, small scale model to help you develop a prototype so you can kind of see if it is going to work. The purpose of a prototype is, again, to see if your model is going to work in the concrete terminology. If it is, it's really a simple visualization to help collaborators decide if it is desirable, if it meets the criteria, if it meets the constraints of your product. Again, if it meets the requirements, that's what your prototype is for. And then you can take the prototype and you can clarify the developmental process. You can change the goals of the model. You can change the specifications. Once that's all complete, you can test it. The testing is an important part. You can test it with a team. You can test it with other groups. And then the engineering materials, you can figure out what materials are better to be used with your prototype. So what did you use to create your prototype, and would it have been better to create it with something different? All right, so 3 properties when you create a prototype. You have your physical, mechanical, and thermal properties. So again, this may come up in a quiz or an activity later. So here are some physical properties. You have density, all right, which is the ratio of an object's mass to its volume. For example, wood is seems like a simple material to measure, but it's really not. Wood materials all have varying densities, all right? Then you have your mechanical properties. Their material described how it will react to physical forces. They're used to classify and identify material. The most common properties considered in this process are strength, hardness, resistance to impact, speed of breakage, and ductility, which is the amount of pressure a material can stand before it fractures. All right, now there's some more specific characteristics that will help you, again, refer back to this slideshow during any testing to help you do well on that test, okay? Then you have, so this is strength and ductility, okay? I saw this on the quiz, so keep that in mind. Then you have thermal properties. Thermal conductivity is the transfer of heat. Okay, so does it, like a thermos company chose this as part of their criteria that they needed to really check on thermal conductivity to make sure that their stuff worked well. And then situation room, what is conductivity? So here's like an example of how they tested it and what they needed to do to figure things out. All right, here's an example of what thermal conductivity is and does. And then chapter 3, steps in the design. So the design process, this is super important for you to understand in this class. The engineering design process is a series of steps. They are sometimes lateral, step by step, but sometimes you can kind of loop back depending on where you're at. There are 8 steps. First, you have to define the problem. What is it that you are trying to learn? What is it that you're trying to fix and solve? And what is the problem? Who has the problem or the need? And why is the problem important to solve? You have to really figure that out first and foremost before you can go any farther. So always evaluate your problem before moving on to anything else. Do background research on your problem. So you have to do some research, do some problem solving yourself. What is it about your problem that you can kind of find out, discover some information, and then figure out what criteria and constraints you are going to add to your requirements. And then brainstorm some solutions. So just kind of go through, list as many ideas as you can come up with to solve that problem. And then from those ideas, take your criteria constraints and chuck the ones that aren't going to work and keep the ones that will work. You want 2 or 3 that may work. And then do some developmental work and refine your improvement solutions from those 2 or 3 that you figured out. And then kind of just, okay, will that work with the criteria and constraints or won't it? And then narrow it down to just one. And then build a prototype for that one and see, will that fit the criteria and constraints? Test it. Make sure all of the criteria and constraints are matched. Test it, make sure it works, and then go, if you need to go back a step or two and rethink a few things or add a few things to match those criteria and constraints, then you can do that. That's called improving on the design. And then once you have all those improvements done, then you share that with your client or with the teacher, whoever that may be. Okay, so chapter 4 talks about engineering specialties. So your personal portfolio, most engineers have a portfolio of their skills, their achievements, and highlights their abilities. That way they can take it from job to job and show off like what they're able to do. So this is tooting your own horn by showing off what you're able to do. These are some careers in engineering. So you have your chemical engineer, your electrical engineer, mechanical, and this is what they do. And then you have your civil engineer, which is your green architect. So our green architect can be a civil engineer. The civil engineer is a green architect for the city, for the public. Our green architect is more of a civil engineer for the private sector. Okay. And then these are additional subject areas in engineering. And then you have biotechnology and what they do, environmental engineering, and then you have fluid mechanics, aerospace engineering, astrodynamics, mathematics, electrotechnology and propulsion, aircraft structure, and then material science. Again, if these are on the test, I would highly recommend you refer back to the slideshow. Don't just guess. Go back to the slideshow and find out the answers. Okay. And then chapter 5, promise after process, emerging innovation. Okay. So this one talks about basically just a common question that arises. A lot of information was shared in this particular slideshow. So the next big challenge in engineering is to find a way to live on Mars in a lunar colony. We've heard this come up. Do we want this to happen? The main problem is the developmental point, cost, things like that. So what do you think? All right, now your knowledge check. Here are your questions. Have a look at those. See where in the slideshow you could answer those before going to your knowledge check. Use the slideshow to help you answer them. All right. And then our activities. So let's have a look at our activities for the unit. Critical thinking questions. Describe an occasion in which an explanatory sketch would be used. So if you go to the slideshow, we can use our slideshow to answer that question. An explanatory sketch explains various aspects of the design concept and must be clearly written for possible clients. So when are you going to use an explanatory sketch? When you are explaining to a client what it is that you would like to build for them or what it is you would like to create for them. Okay, so you are explaining the aspects of your design concept. Okay. While it seems rather obvious that engineers need to consider the end user or the person that you're building for, how might this perspective get lost in the design process? So why are you you're going to get so caught up in what you're doing, you're going to forget about the person you're building for, right? The client. You got to think about the client all the time, or the criteria and the constraints. So think about that. Give an example of a product in which ductility would be a particularly important factor. Explain your answer. Oh, if you forgot what ductility means, then just go to the slideshow and you're going to go to that slide. Here's ductility. It can be measured in many ways. All right, let's see. Ductility, the amount of pressure a material can stand before it fractures. Such materials could be metal, ceramic, or plastic. So why is that important, right? So different material strengths are not always the same. They're variables or temperature. Because of this, it's important to remember that mechanical properties vary considerably, cannot be measured in the same way. So you're going to think about ductility being how it fractures. So an example of a product in which ductility would be particularly important. So a coffee mug, or something I 3D printed, or something made of metal that's going to fracture if I put it in the freezer. Or why would that product be a problem for my clients? Okay, so explain that. Why might a prototype be built with different materials than those used in the final product? So would I build would it be cheaper to build a prototype with cardboard than using metal? Yes. Like, I'm going to build my final product with metal, but I'm not going to build my prototype in metal because that's going to cost me money. right? I mean, think about that. Which of the careers in engineering discussed in the unit appeals to you the most and why? So you're going to go to your slideshow, go to that end where we have that list of careers, and you're going to pick the ones that apply, which ones are interesting to you. Now, this is a you question, so there's no right or wrong answer here. It's the ones that you think is most interesting. Personally, environmental engineering is what, if I wasn't a teacher, this is what I would want to do with my life. I would love to go out and save the universe from potentially getting polluted by everybody and their brother. But that's not how it worked out for me. So that's a you question. So this is 100% no right or wrong answer here, just as long as you answer it. Okay, so that's the critical thinking questions. Discussion questions. Again, using the slideshow to help guide you. So can't see. Computer-aided design, or CAD, is also common in engineering. So students of engineering will be learning one of several popular programs. So do some research online and review some of the most common CAD. If you had to choose one to learn, what would it be and why? Be sure to discuss the features that brought you to your first choice to the top of the list. So what CAD software? I do Tinkercad. So Tinkercad could be one that you use. Was that mentioned in the slideshow? I don't know. Don't recall that one. So Tinkercad, SketchUp, Autodesk, Inventor. Those are some of the ones that you could discuss. If it wasn't mentioned in the slideshow. Tinkercad is one that we will, if you take the design and modeling class, Tinkercad is one that you will learn and actually play with in class. So I can add those in there. Okay. Next question. As much as engineers try to avoid it, end user problems are part of the process. You might have noticed that right after the latest smartphone comes out, there are a slew of articles pointing out what is not working properly with the phone. This is just one example of an end user problem. Go online and find an example of an end user problem. Describe the problem and how the company that created the problem plans to fix it. Include a link to the site where you found the information in your response. Okay, easy peasy. Just find an article that discusses the newest, latest problem with the phone and how they plan on fixing it, and then link the problem for me there. Okay. Next assignment is your lab, and for this one, you are clicking the link here and you are watching the video. And as you watch the video, you are answering the questions. Who is Michael Browning? And describe the sketch shown at the beginning of the talk. Pause the video as you answer the questions so he doesn't get away from you. What was the starting hypothesis of the project? What were the first few steps in the design of a prototype? What did they purchase? How did they experiment? Okay, so you can, you can do this. That way you don't miss any questions. Whatever makes it easier for you, okay? How did they experiment? What happened along the way after the trial and error period? What can you learn? So all of this information is in the video. Got a wicked problem? First tell me how you make toast. So then you're going to click here, go to the TED Talk, and he has all the answers to these questions in there for you. So there's only 4 questions on this one. All right, that's that one. And then finally, sketching it out. So on this one, so sketching is using visual representation for an idea. So you're going to need to create a new machine. It can be something simple, this potato peeler, or something like a flying car. It doesn't have to be anything, it's just going to be something that you come up with in your mind. All right, a basic idea on paper. All right, doesn't have to actually, you're not going to actually create it yet. So focus on the fact that it must be meet a need and design a machine that addresses a need, all right, of someone. Remember, engineering is about thinking beyond the limits. Your drawing should incorporate some basic perspective, which has to do with showing depth in art. So the perspective, I'm thinking it needs to show like height, width, and depth of your object. Okay. So perspective, this gives you these 3 links here. The reason I gave you those 3 links is so you could understand what those perspectives mean in case you don't. These are like basic art classes online. Since I'm not there to kind of show you how to do this, that's what these are for. So it's a 3D representation of an illusion, basically. Okay. So once you've completed your sketch, you can either scan it and put it and submit it like a picture, or take a picture of it real up and close on your camera. If you give it to Miss Martin, she can take it to the computer copier and she can scan it for me and send me, if you put your name on it, she can scan it and send it to me as well. Okay. So your images are not all, that's used to communicate ideas. You also need to write a brief paragraph describing your machine. And you can put that right on the paper if you have room, right on your design. Explain how your design, the how the design you chose helps it perform the need that you have identified, and highlight the features of the design you've included to better meet that need. So these 3 things and your sketch need to be all together. Okay. So on this one, you're going to come up with a need. So say, for example, I babysit someone who can't hold a spoon. And so I need to create a spoon that will strap to this baby's hand. So then I'm going to create a spoon that has a strap that velcros, right? Then I'm going to draw the spoon, and then I'm going to draw the velcro strap, right? And then I'm going to write a report that describes what it is I made and why it is I made that. And then I'm going to highlight the features of the velcro strap. Does that make sense? Hopefully that makes sense. Okay. So you can create anything you want as long as it has a person or a client in mind and a need in mind. Okay, that's what this is for. All right, and then the last activity obviously is the quiz. And then please use the slideshow to your advantage. All right, use the slideshow, use the flashcards, use the vocabulary, so that you only have to take the quiz once. All right, so you can pass it with flying colors. Okay, hopefully that helps. And then I will be submitting task 4 for those of you who are ready for it pretty soon. All right, hopefully this helps. Good luck.